Desk of Ladyada.
Hey everybody, and welcome to yet another Sunday evening Desk of Ladyada. It's me, Ladyada, with me, Mr. Ladyada on camera control.
Can't stop, won't stop.
That's right.
We're running a little bit late, but it's all for good reasons.
It's late 8 o'clock still.
It's all for good reasons.
Yes.
Today, we hung out with Jeff and Ingrid, and here we are at the Adafruit factory. I took a photo with this black and white camera that we rented for other reasons.
Yes.
But I just wanted to say it was great to see Jeff in person. We've worked with Jeff for years now, and it was great to see him in person today.
Taller than expected.
Yeah.
Well, I mean, look. I look quite short.
Yeah. Well, we've only seen each other on HD video.
I know.
So, anyways, tune in this week, Show and Tell, Ask an Engineer on Wednesday. You'll be able to talk to Jeff and more.
That's right.
So this week, Ladyada.
Yes.
We're exhausted, but
I'm exhausted.
but we're doing this.
I'm exhausted, but
what do you want to talk about that we?
Well, I thought we could do a super chill video where I do a STEMMification. I'm kind of going through and just finishing up the last sensors that are I2C only and converting.
People ask if there's a sensor that is not STEMmified. They're like, when is it going to be STEMmified?
I mean, whenever I get to it.
Yeah.
I mean, I'm kind of going backwards in time. I did some really recent ones. I did some very popular ones. I mean, I did do quite a few. We're really getting to many of them at this point. Yeah. And I did this week. I designed the VEML 7700 over. That was actually like the last sensor before we changed over to STEMMA QT. So I think we did that as a leak. But I thought I would do this one, the MPL 3115A2. There's also the MPL 115, but that one is actually being discontinued. It's no longer being made. Let me check. But MPL 11 something.
Well, I've got a question for you.
Mm-hmm.
A question from the audience here. So during this chip shortage, has there been more chips that have been discontinued or more chip introductions?
More have been discontinued because chips are discontinued well in advance, and so that hasn't ended. It's like if they
has it accelerated? Is there more discontinuances?
The parts that were discontinued. It's just that usually you have a little bit longer, but it's just happening. It's the discontinuation cycle is happening. It's just usually it stretches out a little bit longer, and they're just ending it faster.
They're just like, we're not going to even string it along. It's just over.
Yeah, it's really over. So I thought, here is the, this is the MPL. You can see I haven't worked on this since 2016. This is a very old sensor. Oh, no, it's going to make me log in.
Oh,
if you want to switch out, I can log in.
Yeah, if the Prox Trinky Eagle files aren't published yet, they'll probably be up there with the Learn Guide or the repo soon, right?
They'll come eventually.
Yeah. Please don't accuse us of not doing open source anymore.
Don't be a dick.
Yeah, no, look, I think we released it on like a couple days ago. We'll get there.
Yeah.
Yeah.
Okay, I am logged in.
Okay, I'll go back to the...
Okay. Okay, so this is the old file. It's quite ancient, and this is, the old style where, this actually was when we started at least putting the power pins on the left, but there's still, the ordering isn't set for these pins, and so this will change because I now do power, ground, 3-volt clock data, and then, whatever other pins. And also, of course, the shape is going to change. We use a dual FET for level shifting. We still have the level shifting because it's a 3.3 volt chip, and we want to make sure it works at 5 volts, and we have a power regulator. But some things are going to move around a little bit. To make it easy, I actually I have a STEMMA QT like generic layout that I've come up with, and it kind of is like, hey, 90% of my boards are kind of like this. So it has the generic name, description, there's a little spot in the center, and this is where I put the chip. So it's actually not too bad. I can go over to here.
It's a template.
It's a template. And I can grab this and paste it in here. And I just have to change, like this 3.3 volt is, this is a little slightly different symbol. And also, I already have a 0.1 microfarad cap. So I can delete these. I'm going to change this package to be 0603 to match the other one. Other than that, you know, it's kind of almost ready to go. I don't think I'm going to have the 2 interrupt pins. Honestly, I've never even seen anyone use both. So I think, you know, in this design, I'm just going to drop the second interrupt. And I think that's fine. Because that way it fits nicely. And then this goes in here and it just sort of fits. And then I can put this capacitor here. Let me see, this is... Let me update all, just because I think... Yeah, these packages change a little bit.
Do you want some questions tossed your way that is maybe not related?
No, let me finish this and then we can get to stuff. So then, you know, I'd have to route out the board. Which again isn't too bad because, you know, like you can see this is pretty straightforward. You know, I don't have to route everything, just the stuff that's that's new. So, you know, this interrupt line goes there. This goes here. Let me move this around. Let's see, this can go around here this way. This can go around this way. That's how we're doing. 5 air wires. Don't like using this resolution, but it shows it better on the overhead. For this, I can come up here, bring this down, bring it over.
Are you worried AI is going to take over your job?
Not really. I can't even get humans to take over my job.
This is one of the things that no one can handle the nuance of this. Like one day, like so, I did a blog post about how AI. There's a company or a group that's trying to make AI be something that can be listed on a patent, and our patent system is like, hey, it can only be humans. Stop doing this. And so it's like cranking out all these like AI patents and stuff like that.
Yeah, I don't think so.
It's not, and they're just like, look, it came up with a beverage holder. It's like,
yeah.
It's just like, yeah, it's
kind of useless. Okay, so let's see how we're doing.
Yeah, it's like we want to work with the AI and with the robots. It's not a us versus them, because if it's us versus them, they're not going to like design boards like this. Not going to happen.
No, they're very lazy. They really don't want to do work.
If I was an AI, I would just put solar panels in orbit and just be like, hey, I'm going to chill out here for a while.
Hey, I'm done. Yeah, truly. All right, let's see. Let's put in a little ground pad here. Okay, so now we are going to bring this over. Grounds are easy because you can just drop a via. Yeah. Okay, how are we doing? We have 2 air wires. So this one, this is a little annoying, but I think I'll go around here. Okay, how many? Still 2. Okay, down to 1. Question is, where is this via wire? Angle. Clearance. Okay, final air wire is, oh, it's over here. Oh, interesting. Okay, so maybe go like that, and then this is going to complain. about the ground, and I'll put maybe a small via there. Okay. And that's it. Not too bad.
Not too bad.
Do like to make this centered because I'm a little neurotic like that. So I just have to clean it up. Oops. Move this over.
Coming soon to the Nintendo Switch. Super Mario circuits.
Okay. Yeah, I mean, it's not elegant, but it's effective. You know, I sort of take advantage of having a ground plane. I just kind of paste everything into the ground plane. And then I changed the name. I think it was MPL 3115A2, which won't fit. Make that smaller. No, it fits.
Yeah.
And then this is a altimeter. I think it was a pressure altimeter. Yeah. I mean, it's fine. So, you know, this way I can order this on my next time I order, you know, panel PCBs, and, you know, it uses all the standard parts, so that's pretty easy. It does require a new stencil, but I'm kind of used to that at this point, so I don't really care too much. And then I did drop the second interrupt pin, but, you know, I'm kind of okay with that. I don't think anyone ever used the interrupt 2 pin, so I think that's fine. So then I'm just going to save this as, this is MPL 3115A2 Rev B QT. And that's it. That's how I do a STEMMA QT ification. I mean, thankfully the software is
cool.
Identical. I do like to put these in a new folder. And this is, you know, you can see that originally we used number revisions, but then that got really confusing because it's what is minor and major, and like it's got confusing. So we just do rev and letter. So I'll commit these. The only thing is my Git repo is really large. So this can take a while to kind of come together. But I'll and then when it like caches together, I'll commit it. Okay.
Yeah. All right. You want to do some questions before
so
you
do some questions? Yeah.
All right. So first up, random question: which Teensy do you use for your ARM flasher tester?
I tend to use the Teensy 3.6 when I need USB host to test USB enumeration. Otherwise, I actually use a Metro M0. Honestly, I use a Metro M0 and a Metro M4 all the time to do SWD programming. It's fine. You can really use anything. It's all bit banged anyways.
Okay, right now, does Ladyada design all the Adafruit layouts?
Yes.
Boards, yeah. Okay. You've been a huge guiding light in electronics for this person. Cool. If AI could take over your job, that means you're in the wrong job. Probably. Brain insightful. Next up, where'd it go? Oh, why is the angle DRC important?
It isn't. It's just if you are kind of OCD about it, it really doesn't matter. But some people really like it, and so I turn it on and keep it on.
A multiple of 45 degrees is more manufacturable?
No, it doesn't actually matter. But things tend to fit better.
Okay. All right, so let's hit up this week's great search. Ready?
Okay, let's do it.
Okay.
Where in the world is that part I need? The great search with DigiKey.
Every single week we do the Great Search, brought to you by DigiKey. Thank you, DigiKey. And Ladyada uses our powers of engineering and smarts and more to search the DigiKey site to find the parts that you need. Ladyada, what is this week's Great Search?
Okay, this week's Great Search is, it's funny, is half of the time the Great Searches are things that I personally am searching for during the week. that, I can't get or got discontinued or whatnot. And so this week is a part that we use in a lot of our boards for polarity checking. Instead of a diode, like it's polarity verification, or sometimes for turning on and off voltages and stuff, and loads. So let's go to the computer and I'll show you the part. So this is a board that uses an AON 7401. It's a P-channel FET. And in this case, what it's doing is it's verifying that the power that comes in from this DC plug, this power pin, is positive polarity. How does it do that? Well, this is, it's kind of twisted, but this is the gate, this is the source. So this compared to this has to be negative. So if this voltage is negative, this transistor doesn't turn on, and so there's no voltage here. If this is a positive voltage, first off, this does turn on, and also there is a body diode that turns on. So the body diode doesn't matter as much because the transistor gets turned on. But what's nice is that, why use a P-FET instead of just a normal diode? Much lower voltage drop and much higher current throughput, much lower, much less heating because there's a lower voltage drop and current. So, and also they can be a little bit smaller. Diodes are great. Use diodes. These are a little bit more expensive. There's also, these don't have as high a voltage capability, but they're pretty much good enough for most polarity tests that we have to do. So this is AON 7401, and love that AON 7401, except for it's no longer available. It is obsolete, not manufactured. And this actually happens a lot with transistors. Transistors, P-FETs, NFETs, FETs in general, power FETs. I've kind of had to do a couple revisions with them. They seem to kind of cycle in and out. I think that they're based a lot about what manufacturing capability is available, what pricing people are willing to pay, etc. And then they kind of get cycled out. The good news is that there's always other transistors. The bad news is it's a little annoying to find the drop-in replacement. So we've been doing a couple tough ones lately. I thought I'd show this because transistors, it's not like some parts we've shown where it's like, well, I want the exact same specifications. You just want something as good, or maybe as good as your requirement is. Just because this transistor has a VGS max of 20 volts doesn't mean you need your replacement to have it. So you do have to check your design to make sure like what you're using it, and ideally when you design transistors, ironically you think it's like, what's the big deal? It's a transistor. PN2222s are available forever. Specify what is important. Is it the VGS? Is it the RDS on? Is it the capacitance? What is important about the transistor? What specifications do you have to hit? Because when you have to get a new transistor because it went obsolete like this one, you'll have a much, much easier time. So do future you a favor, specify your transistors. That said, let's see what we can do to find a replacement. Now, the first off, I'll open up another page so that we don't, so we can always refer to this. So it does have some specifications that are important. It's a 12 amp ambient, 3.1 watt, ambient, 8 DFN 3x3 package. It's a P-FET, it's a MOSFET. So let's go down and we'll find what do we want to have similar when we're looking for, we want to match up. Well, first off, we need it to be a P-channel MOSFET, okay, no question. But a lot of these other specs, again, you don't necessarily need it to have 14 milliohm RDS on. You just have to have something that has good RDS on. Maybe it has to be 14, but maybe it could be less. 9 is also good. You're not going to match specifications exactly. Each one has very weird mini specs that you're not going to match. So we're not going to be able to match those here. I wouldn't recommend that because you're going to cut down the number way too much. What is important is that you want to have the package match because I really don't want to redesign my PCBs. Chances are you don't either. And I like this 8DFN package. Now the thing about this 8DFN package is it's a kind of a weird package. And it's called different things. Like different companies have packages that are named something similar, and you might be able to use it in the same package, but they're not named the same. Because like once you get into like the DFN land and some QFNs, and like the names get like really weird, especially with MOSFETs. You get like weird cursed packages with like little, gates, and then the drain's massive and the source is like 5 places. So in this case, there's only 6 items that are 8 DFN 3x3, but that's because like there might be other names for them. But if we call it an 8 power VDFN, suddenly like there's 140 options. And so I'm going to go with this because I can then I can drill down by the package size, again knowing that like each company might have a slightly different name. They're called like hyper power FET package. Like who knows the name of the package? It's not standardized like SOIC or TSOP or DIP. A little annoying, but again, this is why we're doing a tough one. I do want something that is active because I'm not going to go through this again in a week. I want to get this done fast. And I'm going to say normal stocking. I don't want to, because I need to buy a bunch of these. I don't want something that's, it's okay if it's not in stock today, because I actually have about a quarter's worth of these transistors. It's just that I'm going to need more real soon. So I'd like to order ahead of time. And as you can see, there's all sorts of like ridiculous names. There's 8DFN 3.3 by 3.3. There's 8DFN 3x3. There's the 5x6, and I'm not going to be able to use that. But I might be able to use the 3.3 by 3.3. So I'm going to have that, and then EP is an extended package. Maybe HSMT I can use. I don't know what these T-SONs, V-SONs, but anything that's about 3x3, toss it in. We'll sort them out later, right? Let's get the options, and we can always look at the data sheets and sort out what we want. Okay, so we got 56 options, and yeah, you can see like they're even if they're called something different, they all kind of have this same game going on here. You can see that there's like these little legs, and then there's this one big package, the heat sink package, and then they look a little bit different maybe, but they're probably all going to work fine as long as the outer shape and the pin pitch is the same. And again, we'll sort those out later. Okay, so what's important here? So what's important to me for this is the RDS-on is kind of important, right? Because I'm passing a lot of current, and honestly, that's going to dictate a lot of what current's being able to pass, and current depends on the heat sinking, blah blah. But the RDS-on is the RDS-on. I want that to be nice and low. Now, thankfully, this one has an RDS-on of 14 milliohms, which is quite nice. And if you look down here, let's see what's available. A lot of them are 14, there's some that are really high, but, I can pick, let's say 18 and below, all of these. So let's filter those out. Another thing is, the VGS, right? What is the max voltage that I want to protect against? And this one is, I think, 25, plus or minus 25 volts. I don't need to be plus or minus 25, but I do want to be over 12. So I'm going to pick out the 12, 20, and 25 VGS maxes. So that gives me 34 options. Capacitance, I don't care about. Power dissipation, I don't think that's going to be an issue really. VGS, threshold, all these are 3 volts or less, and honestly, because this is used for 5 volt power, all of them are used for 5 volt power, so all these are going to be okay. They'll turn on nice and hard. So let's see what is available. Okay, we have a couple options. All of them look pretty good. A lot of like low, milliamp, high, low milliohm, high ampere ratings. I do want to try to get one that's a reasonable price. Oh, one thing I'm gonna do is I'm gonna exclude marketplace items, and then I think I'm also going to, since a lot of these are out of stock, I think I'm gonna do in stock. Yeah, it's like 9. So it looks like we have a couple options here. There's the PXP 018, RQ3 from Rome. All these look pretty good. If I want to be more picky and I want to say only give me, you know, whoops, not this one, the 20 to 25 volts. This gives me 6 options or so. This one is, you know, of course, always sounds great whenever you have something with the same part number, like 7401, AO 7401, DMG 8401. So this one's a good, wait, not in stock.
Uh-oh.
That's weird. It says it's, you know, I noticed this.
Uh-oh.
Sometimes people buy them right when you think. But, you know, for the pricing, and if I need about 1,000, I think this is probably going to be my option. Of course, I'm going to verify that this package works. I'm actually going to buy 5 of these and then solder them on and make sure that they work in the use case I've got. But it looks fine, and there's a couple thousand in stock, and the price is about the same. You know, I can compare the specifications, but they're almost identical, and this has a better RDS on. So this is going to definitely, you know, this says continuous drain 12 amps, and this one is also continuous drain 12 amps. So this is a very nice alternative. It's pretty much a drop-in, as long as the pinout is the same, which it probably will be.
Okay, let me do a question.
Yeah.
Let's assume you don't find a drop-in replacement. Is it worth maintaining 2 variants of the same breakout?
Well, if it's discontinued, then no. You know, if it's discontinued, you just cut your losses and you move on.
Okay, and we'll do one question after the segment's over.
Okay.
That was a great search.
Thanks, everybody.
Where in the world is that part I need? The great search with DigiKey.
All right, so someone had a question is if they're pretty confident in Eagle for obvious use, but they see stuff in KiCad, is there a good way to load up KiCad projects in Eagle? They mostly want to switch from some components or reskin boards from Osh Park After Dark.
I don't know if there's a KiCad to EagleCAD importer. I know there's an EagleCAD to KiCad converter, but I know it's also not perfect.
So
I'd honestly just redraw it. I know it's like not great, but I've done it.
Let me give folks a little bit of maker history that'll never be anywhere. Here you are. You're listening to Maker History. So before Eagle was sold off to Autodesk, Ladyada and I, and Evil Mad Scientist, Wendell, and Lenore, we spent a lot of time talking to that team. They were based out of Germany, and we're just like, hey, please make it so you can export Eagle stuff via like an XML format so it can be imported to KiCad. And they did it, and they listened to us, and that is one of the things that is like around. It'll probably never go away. And it was, I don't know, 7 years ago or so. And we were at, I think, a crossroad for tools for people who do electronics. And now it is the expectation that you should be able to move your board files in some way to other packages, or at least the ones that you can are the ones that people are using. A lot of people start with KiCad, then they go to Eagle. I think that's a good thing. So I don't know another way to go from KiCad to Eagle, but definitely Eagle can export to KiCad.
Yep, XML for the win.
Yeah. So anyways, and you know, it's up to all of us. I think there's a nice way to tell all the tool makers, just like, look, we'll always go with the best tool, so let us move our thing between the tools, and when you're the best tool, we'll be with you. Maybe another way to go about it.
Cool.
And that is this week's Desk of Ladyada. Bye,
Thanks, everybody. Have a great long weekend if you have one. If not, have a happy Monday.
Yeah, bye.